Hello students, this is Rodriguez again, helping you navigate through a Khan Academy assignment. This time we're looking at solving quadratic equations that have or may not have complex solutions. Let's take a look at what we've got here. First, the equation that we're given here is in its standard form where we have our ax plus bx plus c and it's set equal to 0. Now, with that, we need to identify what our a, b, and c are. A, b, and c. And our a comes from this coefficient of the x squared here. So that's going to be 3. Our b is the coefficient of the x term. So that will be a negative 5. And our c will be the constant term here, which is a positive 1. So a is 3, b is negative 5, and c is a positive 1. Okay, what we have to do is use this a, b, and the c in the context of the quadratic formula, which is x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all of that over 2 times a. And we could substitute these three into these parts here and try and figure out the exact values. But I'm confident you know how to do that already. So what I want to do is I want to take advantage of just the parts and the pieces of the quadratic formula to be able to discover which of these 4 solutions it might be. Notice the solutions all have the same elements of 5/6 and a square root of 13 over 6. They're either I or not I. So we either have a complex result or a real number result. The only difference is between the complex and the real number results, one of them has a negative 5/6 and the other one has a positive 5/6. So we can use that information to eliminate wrong answers. So let's start by looking at the opposite of b. In the equation, the opposite part is part of the equation, and then I always suggest, remember, that you put in your value, your b value, in this case negative 5, with a parentheses around it, a set of parentheses. So in our case, our opposite of b would be the negative of negative 5, which would be a positive 5. That automatically eliminates some of our problems, or possible solutions here. This negative 5 is not going to work. Neither will this negative 5/6 here. That's also not going to work. So let's see if between C and B, which one might be the answer. And to do that, what we really need to do is we need to find out our discriminant here. This square root of b squared minus 4ac. Now, what we have to choose from is the square root of 13 over 6 or the square root of 13 over 6i, which would mean a real number 13 over 6 or an imaginary number 13 over 6. Now remember, that imaginary number comes from having a negative square root, so let's see what happens when we substitute our information into b squared minus 4ac. Let's see if we get a positive or a negative number. So b squared is a negative 5 squared, and then minus 4 times a is 3 times c is 1. Now based on this right here, this will tell us whether our discriminant is positive or negative, meaning is that square root of 13 going to be a real number as in B or an imaginary number is in option C. So let's go ahead and simplify this a little bit. Negative 5 times negative 5 is 25. Minus 4 times 3 is 12. Times 1 is also 12. So that's going to be a minus 12. And in this case, 25 minus 12 is a positive 13. So our number in front of the parentheses, a number in front of the plus or minus is a positive 5, and after the plus or minus is a positive square root of 13. So this I does not come into play at all here. So this is also eliminated, which means that our only possible answer is 5, 6 plus or minus the square root of 13 divided by 6. Let's see if that's true. Cool. Just focusing on the opposite of b plus or minus the square root of b squared minus 4ac. So our a term in this case is 3, our b is negative 4, and our c is 2. So b squared, the opposite of b squared, is going to be a positive 4. So that will eliminate this negative here, and it will eliminate, and that's the only thing that gets eliminated. So now we need to be careful and see what happens with our discriminant to see if it's positive or negative. So let's take a look at just that part then. So that'll be, once again, our b squared minus 4 times a times c, or in our case that will be a negative 4 squared minus 4 times 3 times 2. And in this case, we're going to get 16 minus 24, or a square root of a negative. Okay, so this case, we do have the square root of 8i, which eliminates this answer here. So now what we need to figure out is what's going to happen. It'll either be C or D. This one's a little more interesting, so let's compose everything together. We know that our x is going to equal 4 plus or minus square root of 8i divided by 2 times 3. Now, I don't fully expect that everybody watching this is adept at how to completely simplify these kinds of expressions. I know when you're first learning how to simplify quadratics, you may not have some that go quite this deep into the simplifying, and that's okay. We're here right now just to use our logic and reasoning to figure out what the answer is. So I know it comes down to 2 over 6 or 2 over 3, but I also know that 2 times 3 is 6, so this one kind of looks like a strong candidate, except when you realize that 8 is 2 times 4. So when I have 2 times 4, and 4 is a perfect square, and I know that 4 is 2 times 2, then I have a sense that this 2 is going to get eliminated. And so what we're really looking at is 2 times the square root of 2 thirds plus or minus square root of 2 thirds times I. Now that's just a guess. I could be wrong, but let's take a look. There it is. So that's a way to use reasoning to figure out how to get through the solving quadratic equations with complex solutions. I highly encourage you to try this, and I highly encourage you to do it without actually going through each and every part of the quadratic formula here, but just trying to reason your way through it as best you can. Good luck.